Thyristors or silicon-controlled rectifiers, SCR, find many uses in electronics, and in particular for power control. These devices have even been called the workhorse of high-power electronics. Thyristors are able to switch large levels of power, accordingly they used in a wide variety of different applications. Thyristors even finds uses in low-power electronics where they are used in many circuits from light dimmers to power supply over voltage protection. The term SCR or silicon-controlled rectifier is often used synonymously with that of thyristor. The SCR or silicon-controlled rectifier is actually a trade name used by General Electric. In this video we will learn about silicon-controlled rectifier SCR. The idea for the thyristor was first described by Shockley in 1950. It was referred to as a bipolar transistor with a p-n hook collector. The mechanism for the operation was analyzed further in 1952 by Ebers. Then in 1956 Small investigated the switching mechanism of the thyristor. Development continued and more was learned about the device such that the first silicon-controlled rectifiers became available in the early 1960s, where it started to gain a significant level of popularity for power switching. Applications of thyristor. Thyristors, or silicon-controlled rectifiers, SCRs, are used in many areas of electronics where they find uses in a variety of different applications. Some of the more common applications for them are outlined below: AC power control including lights, motors, etc. Overvoltage protection crowbar for power supplies. AC power switching. Control elements in phase angle triggered controllers. Within photographic flashlights, where they act as the switch to discharge a stored voltage through the flash lamp, and then cut it off at the required time. Thyristors are able to switch high voltages and withstand reverse voltages, making them ideal for switching applications, especially within AC scenarios. Symbol of thyristor. The silicon-controlled rectifier, SCR or thyristor symbol used for circuit diagrams or circuit seeks to emphasize its rectifier characteristics while also showing the control gate. As a result, the thyristor symbol shows the traditional diode symbol with a control gate entering near the junction. Basics. Working principle of thyristor. The thyristor or silicon-controlled rectifier, SCR, is a device that has a number of unusual characteristics. It has three terminals: anode, cathode and gate, reflecting thermionic valve/vacuum tube technology. As might be expected, the gate is the control terminal while the main current flows between the anode and cathode. As can be imagined from its circuit symbol shown below, the device is a one-way device, giving rise to the GE name for it, the silicon-controlled rectifier. Therefore, when the device is used with AC, it will only conduct for a maximum of half the cycle. In operation, the thyristor or SCR will not conduct initially. It requires a certain level of current to flow in the gate to fire it. Once fired, the thyristor will remain in conduction until the voltage across the anode and cathode is removed. This obviously happens at the end of the half cycle over which the thyristor conducts. The next half cycle will be blocked as a result of the rectifier action. It will then require current in the gate circuit to fire the SCR again. Thanks for watching this video. You will learn more about semiconductor. Check out my videos What is the work of diode and different types of diode. Don't forget like and share. More update, please subscribe my channel Learning Engineering.